Welcome back to the latest episode in this series documenting the build of guitar number 85. In the last episode, we left off with me finishing up the fretwork. And now we pick up where we left off. Okay guys, we're going to take a break from fretwork for a little bit now and switch over to some bridge work here. I just located the bridge and I drilled these two holes so that its location is now referenced. I don't have to locate it again later. So that's good to go. I know exactly where this bridge is supposed to be glued. But before I glue it, I want to check the height and then level the bridge to get it to an appropriate height for the height of our fret tops. So if I take a straight edge and reference that right off the fret tops just like this, then the end of this straight edge, as it extrapolates out over the top, this should glide right over the top of the bridge, kind of like that. And actually, I always think it should glide a little bit more than just right over the top of the bridge. It shouldn't, so it's better in my opinion if it doesn't kiss the bridge, but rather if it sits up about a 32nd of an inch off of the bridge. This kind of stuff is all important for getting an appropriate saddle height later on. If you get this dramatically wrong, then you can't really set your action within an appropriate range. And so you end up being forced to either create a super tall saddle or to create a saddle that just barely pokes up out of the bridge. So again, we want the straight edge to glide across all the fret tops and then just over the bridge, leaving a 32nd of an inch gap. And right now, it's just barely bumping into it. So if I lower this just a little bit more, then the straight edge will glide over it, and a little bit more than that, and we'll have our 32nd of an inch gap. Okay guys, so now I'm ready to glue the bridge on. So we're going to take a break from all that fretwork and everything else and glue this bridge, which looks kind of like a mustache. And that's actually the problem that I'm running up against right now, is this mustache-shaped bridge doesn't look like your typical guitar bridge, which has these squared off wings. And so usually my way of gluing down the bridge involves using a Fox-style bridge clamp. Here, and let me show you what this looks like with the bolts in there. So this is the system I normally like to use, but this assumes that you will have those squared off, or at least something similar to this. For this, I'm going to have to actually make a separate, a special custom bridge clamp, which I've done before in the past for other odd bridge shapes, just making it out of a hardwood, some brass inserts, and some bolts. Now, if I wanted to, the easy way out would be to simply use a couple of Ibex bridge clamps. There's a way to arrange these to make that work. But since I know I'm going to be doing more of this bridge shape, not all the time, but sometimes in the future, I want to go ahead and make one of these bridge clamps simply because it's a little bit easier, it's more repeatable. And what I really like about this system, the whole reason I migrated to it in the first place, is because it doesn't involve a bunch of clamps that then get in the way of both glue squeeze out cleanup and get in the way of jumping back to working on your fretwork or whatever other part of the guitar you want while that glue is drying. With the bridge clamp set up, you're basically left waiting for the glue to cure, which means you're waiting at least overnight before you do work on the rest of the guitar. So I like this. Alright, so here I have a nice piece of hardwood. This is actually excessively hardwood. This is a piece of catalloche. I could probably just use a piece of oak or something like that, but this is what I have. And this is also what I used on the last time I made a bridge clamp, so I'm going to go with the catalloche. So I start out by tracing out my bridge shape onto my piece of catalloche. And after that, I'm just freehanding a line that is outside of that shape. This will be the cut line. Here I'm just marking where I want to drill my holes for the brass inserts, which will hold the bolts that are used to clamp down the wings of the bridge. And then the last thing I'm marking is where the E-string holes will be. Then I install my brass inserts at the tips of the wings, and I cut out the general shape on the bandsaw. And now I've drilled the holes for the bolts. And lastly, what I want to do is drill some more holes on either side of these, and then just take a file and file across those holes to connect them and create a slot like you see on this other version here. Instead of holes, we want slots, simply because that will make alignment much more adaptable to your bridge, rather than these holes having to be, dead on perfect, and also, these points to be dead on perfect as well. You have wiggle room if you slot out these holes. Alright, notice the 3 holes, and now I'm going to connect them. Alright, ladies and gentlemen, and there you have it. So now these bolts go right in there, and they can move around freely, side to side. Okay, I'm excited now to glue down with my customizable Fox style bridge clamp to glue down this unique bridge. Alright, let's go ahead and do that. First, I just clean and smooth the lower bout area of the top where the bridge will go in preparation for the glue up. Alright, now let's get those bolts to just barely poke out, so we have something to catch our hole with. Okay, bolts are sticking out. Let's see if I can stick the landing here. Okay, good. Nice, landed on the holes. Tighten that down. These little nuts go on the inside. Don't want to over tighten these. You can use an Allen wrench to tighten them, but in a lot of cases you don't even want to use the Allen wrench, hand tight is enough. If you over tighten them, you can actually push a gap out to the middle of the bridge, so it won't be as tight of a fit, ironically. It's not that I'd be worried about cracking the top necessarily by over tightening these. It's actually that I would force a gap into the middle. Alright, any glue squeeze out you want to clean up, there's really just this one dot right here. Very careful not to scrape the top with my cleanup stick. Okay guys, I just took the bridge clamp off, and this is always a glorious moment here because really the build is over at this point. The guitar is built. There's still lots of work to be done, but that work really falls into different categories. It's not really a build anymore. Now we're doing setup work, we're doing finish work. We'll be doing as well. There'll be a lot of touch-up and sanding, of course. But you know what there won't be any more of? We're not going to be shaping and assembling any more new parts. That's why I say the build is complete. Alright, and I just finished fitting the nut. You can hear that nice creaking sound. Fitting the nut as in thicknessing it so that it fits this slot perfectly, and that creak tells you that it does fit perfectly. And what tells you even more, this is the true test right here, is when you can pick up the guitar by the nut. That's pretty cool. Not required necessarily, it can be looser than that, but it's just kind of a cool thing. I'm still wearing my mask here. I'm wearing this mask because the bone dust is particularly nasty stuff, so you definitely want to wear a mask when you're sanding this. You should wear a mask often when you're sanding. I don't wear it all the time when I'm sanding, but definitely when I'm sanding bone dust. Okay, so now that I have the nut in place, we're going to jump over to this saddle, and I'm going to mark out very precisely where I want that saddle to be. And there's a very easy way to do this that I like, which is using this StewMac, what's it called? The Saddle-matic tool. And it's kind of a gimmicky tool. It's one of those unnecessary tools, but if you have it, you might as well use it kind of things. Because you can just mark this out with a ruler, of course, if you have your numbers. And the way this works is I butt this block up against the nut, and then I set this adjustable block down here on the 12th fret. Okay? So now the distance from the end of this block to this block is exactly half of our nominal scale length. So if I pick this up then and spin it around and now place the block back on the 12th fret, well then now the end of this block is double what it was before, so it is our full nominal scale length. Nominal scale length means the scale length in name. That's literally what nominal means. So what we want though is not the scale length, the nominal scale length, the scale length in name. What we want is the scale length plus compensation. And it's a little too much to get into a full discussion of what compensation is here, but just suffice it to say that compensation is a little bit of extra length that we're adding to our scale length. It's very small, less than 1/8 of an inch, less than the 1/16 of an inch on the treble side. And of course that varies based on what your scale length is and different string gauges, yada yada. But the point is, it is a tiny bit of extra length to our scale length, which compensates for real world factors like the fact that the strings stretch every time you press them down to the frets. You actually stretch the string out just a little bit, which actually sharpens, that stretching sharpens the pitch slightly more than we want it to. So by lengthening that string, we compensate just a little bit. Again, I don't want to get into a full discussion of compensation, but there you go. I got into a partial discussion of compensation. All right, so the cool thing about this tool is you just flip it around and then press down, and it gives you 2 little marks for your compensation. So again, from this block to the end of this block is the nominal scale length, but then these little pincers here on the end, these are set up to represent the compensation. Now I'm cutting my saddle slot using the StewMac saddle routing jig and a Dremel. And I'm using an 1/8 of an inch spiral downcut bit. This will give me an 1/8 of an inch wide saddle. Getting to my full depth for the saddle slot occurs over many, many shallow passes. Okay, everybody out there, so I am at the stage now where I'm installing my tuners, which happen to be these Steinberger Gearless Tuners. So they are gearless in the sense that they are not normal tuners that have the knob on the side where you turn the knob, which turns a gear, which then turns the post, right? So this string can wrap around the post. This is a whole new conception of tuners where the string actually doesn't wrap around the post. The string actually gets installed into a little hole in the bottom of this shaft that I just pushed up, and then when you turn the shaft, it actually lowers, it descends down into the headstock. So rather than twisting the string around it, it pulls it down into the headstock. It's pretty cool. The benefit of it is you get basically the equivalent of a 40-to-1 tuning ratio. To give you some perspective on that, 16-to-1 is a pretty common tuning ratio. 18-to-1 is a stellar tuning ratio. 21-to-1 is the highest I've ever heard of. That is before Steinberger. So really the highest is the 40-to-1, which we have right here. So it's really in a whole nother world all its own. When I say it's the highest tuning ratio, that's actually a little misleading, because it's not geared, it's gearless. So that 40-to-1 just means that it's the equivalent. It feels like a 40-to-1 gear ratio, but it's actually gearless. Okay. What I'm doing here is I'm experimenting with these Steinberger Gearless Tuners, and at the same time, I'm also experimenting with countersinking my tuners using this thing here. So I'm being a little bit dangerous here, experimenting with two things at once, two new things, the new cool kind of tuner that I want to try out, and also countersinking the tops of those tuners in there. So just to give you an idea, and by the way, I'm doing that, the countersinking is mostly for aesthetic reasons. It's also good for the finish to have them countersunk in there, at least for the long-term longevity of the finish, because there's a common problem in old guitars that you see with crackling and lifting around the tuners from years of the tuners resting on top of the finish and kind of being tightened down onto that finish. It crackles it and lifts the ends up. But if you actually countersink the tuner into the wood, you don't have that problem. Aside from that, I think on these Steinberger tuners, they have a really fat top to them. It's not correct to call that the washer, because it's not a washer, but this top portion, hold on, my humidifier kicked on. I want to turn that off. Okay, so this top portion of the tuner is kind of thick in my opinion, so I'm actually burying it into the headstock, and I think it looks really seamless and slick that way. Just to let you know how far down it's buried, I put this one in there, which I haven't countersunk yet. Well, actually I have to drill this. I have to drill a hole here for the set pin. Let me just do that real quick, and then you can see how high up a non-countersunk tuner sits. So first I just place that on there. Give it a couple whacks with a dead blow hammer, which leaves a little mark. Small 1/16 of an inch bit here. I'm intentionally angling inward a little bit, otherwise that bit is so close to the hole's edge that it slips into the hole. So now that pin has something to reference into. Don't worry, it's a brass head. It's not doing any damage. Okay, So you can see how the one I'm countersinking, I might countersink this further, but I might leave it there. And then the one in the back here is, you can tell it's sitting up on the surface. So this, in my opinion, is kind of slick and kind of cool. So I'm gonna keep doing it. Now this counter boring tool here that I got is really designed to work in a drill press, and this is also new here in the shop. I haven't used it much, but I actually think what I'm going to end up doing is fastening a handle to this and using it like you would use a reamer. I know it's not designed for that, but it actually works quite well that way. Alright, so that's the plan. I like it. I like how it looks. I like how these tuners feel so far. I have used them a little bit before, so also I like their function. So I'm just going to keep on keeping on here with these, with countersinking these. And here, just to give you a little bit of a preview of this guitar, we are on the home stretch here for guitar number 85. I have strings on guitar number 85 now. Very, very exciting. All I have to do is slot this nut. So the rule of thumb is this. It's very simple. It's, you want the file size that matches the string gauge. So this is 12 thousandths of an inch. So I would need a 12 thousandths of an inch file. If I don't have 12 thousandths of an inch, I want the next size up, always up. Never lower. So let's say if I had an 11 thousandths of an inch file and a 16 thousandths of an inch file, you might think I'll go with the 11, it's closer, but no, it's less, so I don't want it. I want the next size up, so I would go all the way up to the 16. And yeah, it would be a little extra wide, but that would be okay. That's better than having even slightly too small of a slot for the gauge of your string. The most important thing that I'm doing here is I'm angling my notch so that it peaks at the front edge, the fretboard facing edge of the nut. If you just file a notch holding this flat, then the break point of the string will be wherever the highest point of that flat ramp is. And it might be in the middle, it might be in the back edge, or you might get lucky and it is actually at the very front, which is where you want it. So we want to know that it's at the front, so what we're going to do is angle this like this, so that for sure that string will peak right here, and that will be the starting point or the breaking point of the string over the nut. Doesn't matter what the angle is, just that it's angled up. Conveniently enough, we have an angle right here. It's our headstock angle. So I just eyeball the headstock angle and try and follow the headstock angle. And finally, I can prepare all the surfaces for finish. I can use the random orbital sander on the plates for the bulk of the sanding, but I always finish up with some hand sanding with 220 grit. I will be applying a Tru-Oil finish for this guitar in the same method that I teach in my online course. This method has a lot of crossover and similarities with French polish. What you are watching here is me applying one of many applications of Tru-Oil to this guitar. So the actual finishing process really occurs over the entire week. In the end, I will have around 20 applications of Tru-Oil. And so I leave you off here. In the next and final episode, I will reveal guitar number 85. If you learned something here, please give this video a like and subscribe so you can be notified when I release a new DIY guitar making video. And if you want to really learn more, take one of my structured online courses at ericschaferguitars.com or register for a hands-on guitar building workshop here with me in Burnville, Pennsylvania.